logarithm has laws that are dual to the laws of exponents. For example, b to the 0 is 1, so log base b of 1 is 0. B to the first is b, so log base b of b is 1. And logarithm and exponential base b cancel here and here. Now, one rule of exponents is that a to a sum is a product. A to the x plus y is a to the x times a to the y. Exponential turns plus into times. Logarithm does the other way around. It's a logarithm of a product is a sum. Log base b of xy is log x, log base b of x plus log base b of y. Exponentials turns differences into quotients. A to the x, a to the power x minus y is a to the x over a to the y. Well, logarithm goes the other way around. It turns division into subtraction. Log base b of x over y is log base b of x minus log base b of y. Exponential, x to the p, you can think of it as repeated multiplication. And it's a logarithm of an exponent, of a power, is repeated addition, which is multiplication. So log base b of x to the p is p log base b of x. There's a question about how to relate logarithms to any base to common logs, say, or natural logs. Because in your calculator, you'll see that it has a log, common log button here, and a natural log, log base e button here. But suppose you had to find log base 1.05, which you might if you're doing, say, a compound interest. How long does something at 5% interest take to double? Well, you have to take log base 1.05 of 2. So how to find log base b of x given, say, common log or natural log? Well, log base b of x is a ratio of logarithms. It's common log of x over common log of b, or natural log of x over natural log of b, or log base a of x over log base a of b. Now we can derive this by calculation, and the book goes into that. Perhaps sometime if you wish I could go over this. But more to the point, let's use these rules. So for example, let's see the virtues of these logarithm laws. It turns complicated functions, times, divide, and powers, into somewhat simpler functions, plus, minus, and multiple. So it sort of brings things down one level in complexity. So log, to simplify, log of 7c over 2. Well, it's this is log of a quotient, so it's a difference. Log 7c minus log 2. 7c is a product, so its logarithm is a sum. Log 7 plus log c minus log 2. Here we have, to simplify, common log of x to the third, y to the second. Well, this is a log of a product, so it's a sum of logarithms. Log of x to the third plus log of y to the second. And this x to the third is x times x times x, so it's log x plus log x plus log x, or 3 log x. Log of y squared is log of y times y, so it's log y plus log y, or twice log y. So logarithm of power comes outside the logarithm. Now here's going to be a little tricky one. This is tricky two ways. We're talking about roots, which are fractional powers, and then we're dividing by a product. So you're going to have to watch out there. Log base a of root 3 of x divided by root 4 of yz. Okay, log of a quotient is a difference. Log base a of x to the 1/3 of the cube root of x minus log base a of 4th root of yz. Okay, you're right. The third root is a 1/3 power here. This 4th root is a 1/4 power here. So log base a of x to the third minus log base a of yz to the 1/4. The powers come outside the logarithms here and here. So 1/3 log base a of x minus 1/4 log base a of yz. Now here's where it gets a little complicated and I have to watch out. Log base a of yz, well, it's a product, so it becomes a logarithm of a sum. But I strongly recommend that you put this in parentheses, lest you get a sign wrong later on. So you get 1/3 log base a of x minus 1/4 of the sum, log base a of y plus log base a of z. Last step, distribute the minus 1/4, then you get 1/3 log base a of x minus 1/4 log base a of y minus 1/4 log base a of z. Now, this parentheses was necessary because if you didn't write the parenthesis, you'd be tempted to write a plus here, which is wrong. The z is in the denominator, so therefore you have to subtract the logarithm. So be careful about that when you're asking for logarithm of a reciprocal with a product, because you'll get minus log rather than minus log plus log. That's a common error. Please avoid it. Here's log base 5 of a 1 over t cubed to the d power. What's that? Well, out comes a d log base 5 of t 1 over t third. Write this as a t to the negative third, d log base 5 of t to the negative third. Bring out the negative 3 and you get negative 3d log base 5 of t. Now here we're going to do this simplifying process in reverse. We start as a sum of multiples of logarithms, and we want to write it as a single logarithm. Minus 3 log base b of x minus 2 log base b of y plus a half log base b of z. What's that? Okay, the 1 minus 3 goes in the logarithm as a power, log base b of x to the negative third. This minus 2 goes into it as a power plus log base b of y to the negative 2. The half goes into the logarithm as a power, log base b of y to the half. Okay, now we have a sum of logarithms. That's a logarithm of a product. Log base b of x to the negative third, y to the negative 2, z to the half. And we'll rewrite that. The half power is the square root and the negative power is in the quotient. So log base b of square root of z over the quantity x cubed y squared. Now, here we're asking to estimate logarithms to 4 places. Log base 3 of 7, what's that? Well, it's log 7, common log of 7 over common log of 3. Ratio of these two numbers, yada, yada, push a button, calculator said about 1.7712. And of course, if you had a graphing calculator, you wouldn't really even need to stop here. You just write the expression with these in parentheses and get that. Log base 3 of 8, that's common log of 8 over common log of 3, yada, 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 about 1.8928. Here they ask which of these two are equal. I'm sorry, this looks like 114. I really should have it. Is 11 to the 4th. Like base 2 of 11 to the 4th, 4 log base 2 of 11, and log base 2 of 11, all that to the 4th. Well, these are equal because the 4 comes outside. This is not equal to the others because, well, 4 times something is not the same thing to the 4th power. So A and B are equal. Okay.